see a bunch of stuff coming on. One says current, and there's a digital readout of voltage. Okay, so this I'm not exactly plugging in. Actually, I can turn some more light on if you want to. Get this going. Yeah, I'll turn it this way so everybody can get a look. Fortunately, this is not one of these goggle things.
So we can stand somewhat close now?
Yeah, after they're hooked up. So let's see. Hook that one up to the red. What we do is rotate that like that, and then you slip that in. Oh, that makes sense. I'll get this guy too.
Which one's positive and negative?
You remember your colors? Red is positive. Okay, so this one is sitting there, and what we'll be doing is we get positive and negative. Which one is going to be getting more electrons? Where are we passing the electrons? If this is positive and this is negative. The negative.
Negative.
The negative. Okay, so we're going to be pumping electrons into here. So which one do you want to be that? Well, I'll make it this one. Okay. So what we have over here is an electrode stuck inside essentially what is water. So this is a reservoir for water, and this stopper is just there to keep it from evaporating too much. I'll leave it there for a moment. And what will happen is, as we do this, there'll be a reaction going across here. So here are two what are called burettes, which are graduated. They have little bits of measuring, they have markings on them to measure them. And let's see, I need to get this one all the way up to the top. There, okay. And that one's pretty much up there too. Now, there's one thing I forgot. I need to get a couple of test tubes. Okay, that should work like that. And then I'll get this going. Okay, so at this time, we have these two burettes, and they're graduated, so we can see how much has been, how much of the water, or how much of, actually, it's going to be some gas, is going to be displacing this liquid in here. So we're going to see these gradually, these water levels go down a little bit. Okay, make sure everybody can see over here too. Okay, or you can gather around, something like that. So to get this to work, we have water in here, and let me go over here. You can draw this down too. We have to have an electrolyte in there. That is something that's able to pass the current. So we actually have something called sodium sulfate.
Sodium sulfate, okay.
Which is aqueous because we put it in the water. It's normally just a regular salt, and this is divided out into two sodiums, aqueous, and they split apart, of course, and one sulfate, and that would be aqueous as well. So because this is, that's a negative 2, this is a positive 1, and 2 of those. Let's put the coefficient in front. And so this would be able to go, which direction would this one probably go if it's migrating here? To the positive or the negative?
Negative.
To the negative. And why is that?
Because it's got a positive charge.
That makes sense. And so, of course, this guy would be going the other direction. Now these, when they get to the electrode, the thing that has an excess of electrons, this gets over there. Well, it turns out that doesn't plate out and become a solid because it takes a lot more energy to do that. Instead, it would take the water and rip it apart. And water rips apart. We take this, and I believe I showed this yesterday. So this is the liquid water. And when we put some, let's say, energy into that, electrical energy, then we'll get one of these, 2, 3, 4, 5, 6. How many valence electrons does oxygen have?
6.
Okay, we have one of those, and then we'll get some hydrogen, which is like that. There's a covalent bond between there. So what's the valence electrons for hydrogen? How many does that have? 1. So I can write this one like that. This would be for just regular oxygen. Would be like this if we had it in the atmosphere. Okay, so it splits apart into this and this, so there would of course be 2 of these from that. I showed you yesterday. These are called free radicals. Did I show you that? Or was it my other class? You did.
You did.
So we have the unpaired electrons there, where I'm circling those. Okay, free radicals react pretty much immediately, whoever happens to be around. Okay, so that's what I'm going to be doing. And these little, I'm afraid they're called stopcocks. Please don't read too much into that, but I'm afraid that's what they are called. This allows, if I turn this way, then it allows whatever's in here to move up. So if we have some gas in here and I rotated this, the liquid would then push this up because, of course, we have this extra liquid up here, which is water, sodium sulfate solution, would then be, has enough weight to push this down and force that up. Okay, so now we're going to get started with this. And I'm going to, let's see, which one is that? Force. Okay, volume, current. Okay, so I've turned this up to about 19 volts. And what's going on here? You can come up and get close now.
Oh yeah, it's bubbling.
Okay, so what's going on there?
Gas release.
Yeah, where'd the gas come from? Did you eat something?
You're separating the hydrogen and the oxygen from itself.
From itself?
Well, I mean, from the water.
Yeah,
It's
the water's
becoming.
breaking apart into pieces.
Is it becoming H2 and O2?
Sounds like a good guess, okay, because that's what we have. Now, why is it going into H with 1 electron and O with 6 electrons? Or is it coming directly out as O2 and H2?
I bet they're like very quickly bonding with each other right after they're separated.
Whoa, that's exactly right. I was hoping to catch you on that, but no. They actually do break apart into that first, so you had to supply energy into it to have them break apart. So there's a totally unstable stage. Immediately after that, they come together and form H2 and O2.
Can we say this is electron and hydrogen, and then we say this is oxygen and hydrogen?
Yes, okay. So one is hydrogen, H2, and the other one is O2 when these gases are forming. Now the question is,
I can't believe.
which is which? You can't see it?
I can see.
You can see it now?
Yeah,
Okay.
yeah.
Hopefully other people can with their, I guess everyone can see it, right? You guys can see it?
Nope, that's unfocused. Oh dear.
Which one has more gas displacement?
I would guess this one's the hydrogen.
I
this
think.
one's the
I
oxygen.
think.
Do you want to?
Yeah, I think
don't know.
this is
think
hydrogen.
most-
I think it's
So
hydrogen.
which one do you think would be the oxygen and which one's the hydrogen?
The hydrogen is a
Hydrogen
ratio of
is
2 to
more.
1.
Well, the
so they would
hydrogen
have
is
twice
being
the
a-
volume displacement.
Yeah, yeah.
Yeah.
It's
Really?
the hydrogen. This is oxygen.
Well,
Twice the volume displacement?
I mean,
No,
so
no,
if you
no.
had pure hydrogen, and in this ratio, since it's
I need to
H2O,
go fast.
you have 2 hydrogens for every oxygen, so it has twice the volume.
Okay, so the thing is,
Or not twice the volume, twice the number of atoms.
What happens to the sodium?
molecules.
What happens to the sodium and the sulfate?
That's what I covered at the beginning. It just sits there because the water would rather break apart first than have the sodium and the sulfate played out. So the sulfate does not become, fortunately, sulfur dioxide gas.
Right.
It takes too much energy to do that.
I can't be.
So we'd rather put the energy into the water, creating the gas. Okay, now, if you've got that, which would be which? Which would be the hydrogen and which would be the oxygen?
Hydrogen, oxygen.
Okay, now how could you tell that?
Because I think it go faster. So here has like the double.
It goes faster?
electrons. Yeah, go faster.
So it's like making bubbles faster.
Yeah, that's
on
what I
that
think.
one. Okay, well, why doesn't it go the other way?
Use the positive and negative charges.
Okay, so explain how that's working here. Because you can't.
I know that's what's happening, but I'm not sure how.
Okay, somebody knows. One of them is negative, meaning it's pushing electrons. Yes.
Does it have to do with the oxygen being on the positive side because it's an electronegative element? Very strong electronegativity.
Okay, so what's happening is, if that has a very strong electronegativity, then we would have, actually we have lone pairs and so on sticking out there. The hydrogen on the water, so let me draw this over here. Again, just the water. Come on, you know what this is. So we have this being like that, and this being pulled away from the hydrogen now, the electrons, the covalent bond like that. So we have an excess of negative charge on that side. So what happens is, which end would be attracted to the positive?
Oxidation.
That, of course. So we have this. It's in contact first, the oxygen, with the positive. So it would be taking these electrons away, or essentially, if you're taking electrons away from something, what do you call that as far as a reaction? It's a redox, right? Yeah, it's an oxidation reduction. So who's being oxidized?
Oxygen.
Oxygen. Isn't that weird? Oxygen's getting oxidized. Because usually oxidation is usually considered when you add oxygen to something. In this case, you're getting this weird situation. The hydrogen, now of course, this being more positive, is going to be attracted to what?
Hydrogen.
the negative
The
power.
negative charge.
Okay, where there's an excess of these. And so if this is being oxidized, the hydrogen is being,
Reduced.
thank you. Somebody has to say, you know what it is. So somebody has to say it. Okay, so that's being reduced, and so this becomes exactly like we're showing it over there. We turn it first into the free radicals. We have to break it apart. That's why it takes some additional energy to do that first, and then it's able to produce this, like that. And so what we're going to do is we'll let this go for a while. Now, do you see the gas actually collecting as far as volume up there?
Yeah.
Okay. Now you'll be able to see it really close up.
Thank you.
I'll take a look at it too. It would have been good if I'd started this at the beginning of class. Yeah, it's kind of foamy, I guess maybe because
Foaming at the top.
because the sodium sulfate's holding the water together, making it more less viscous. So anyway, you see a little bit of sodium sulfate got dried up and spit out there. Put that over. There's still air able to get in, but or at least that make it a little easier for this to move like that. So there is current moving through here as well because we have a full circuit moving from the negative over to the positive.